Yo, so we talking about angle of inclination. Yeah, we're talking about angle of inclination. Yeah. I mean, it's this is something that is so cool, that I think you should know. I think what's more important here is knowing how to use the angle of inclination. That's more important. Also, here your trigonometry has to be like a bit solid because we're going back to trigonometry. So you have an angle theta here, and if we were to calculate what tan theta is, so tan theta is going to be the opposite over the adjacent, right? Yeah, opposite over the adjacent. So yeah, and in this case, in our diagram, triangle ABC, that's just changing y over changing x, which is gradient, né? And that is m. So from that, it's easy for us to then conclude to say gradient is the same as tan theta, right? Yeah. And I mean, like, changing y is y1 minus y2 here. For example, in this straight line, you see this straight line here, you have the same x value. So if you want a distance there, you just say y2 minus y1 or y1 minus y2, absolute value of those, and then you're going to get your answer. So the same applies for x, changing x. So I mean, yeah, let me not stretch it too much, but yeah, that's what it is. That's how it is done. Yeah, and we're just talking trigonometry. Yeah, so that is the case within that interval, 0 degrees, theta being between 0 degrees and 180 degrees, right? So yeah, man, let's we cannot further stretch it. To sort of have an idea of what it is we're talking about, let's go do some examples. So here they say determine the gradient, and we are correcting to one decimal place. One decimal place. So yeah, determine the gradient. I'll use a black, no, red. Determine the gradient of each of the following straight lines. Give the angle of inclination. Oh, given the angle of inclination. So like we said, this angle A is between the intervals. So for A, we will just say M is equals to tan what? Tan theta, right? And what is tan theta? It's tan 60. Uh, so this, like, remember, 60 degrees is one of the special angles. This is back in trigonometry. 60 degrees is one of the special angles, and yeah, you can just get the answer without using the calculator. It's from that right angled triangle where you have 30 degrees and this is 60. Sine 30, that's 1 over 2, and this is square root of 3. So tan, it's opposite over adjacent. So opposite, the answer is just going to be square root of 3, right? Let's test the theory. Tan 60, right? So yeah, man, I was right. Square root of 3, which, writing our answer to one decimal point, that's just 1.7. That's our gradient, né? And then, yeah, yeah. Do I have space at the back? Let me see. No, I don't have space. Cool. So I'm gonna take I might as well just erase this. Maybe should I move it? Nah, I'm gonna. Okay, cool. Let me. Yeah. So yeah, the next one is just a simple one. Also, no sweat, no sweat. Yeah, it's just you saying what gradient is equals to tan theta, right? And tan theta, it's tan 135 degrees. You go to your calculator, tan 135 degrees. You get what? You get -1. Ne? So yeah. And let me show you something. This is just a little bit of trigonometry. Um, Remember this kind of, it looks like, let me see 180 minus 45. Yes, so this looks like, when you have tan 180 minus theta, the answer is gonna be minus tan theta, right? And in this case, if we take tan 180 minus 45, it's gonna be negative tan 45. Damn. Negative tan 45. And then tan 45, one of the special angles as well. The answer is just gonna be 1/1, which is 1. So yeah, man, this is some light work. Try not to. I think with angle of inclination, the tricky part here can be the trigonometry part, right? So just be careful, guys. Be careful with the trigonometry here. Make sure your trigonometry is very solid. I believe this will be the last examples I have on the angle of inclination. So we determine the angle of inclination and we correct the following to one decimal place. So the first one, right? The first one, so I can say here we sort of have, let me not say equals to, but rather this arrow and say what? I can say I have y is equals to 1/2x plus 3. Yeah, I just transposed my x and then I divided by 2, right? So that's what I have, and I know that this is what? I know this is my gradient. So now I take number 1 and I say gradient is equals to tan theta. I'm looking for theta, so that means I'm gonna go like tan yebo, right? My angle here, it was what? Half. Not my angle, my gradient. Damn. Damn. I accidentally dropped the phone, but yeah. Yeah. Got distracted. Yeah, that call came out of nowhere. So yeah, I go here, shift tan 0.5, which is half, ne? And I'm getting what? I'm getting 26.6 degrees, ne? That will be the answer for the first one, right? Cool. What about B? B, for us to do B, firstly we're gonna have to calculate what? We're gonna have to calculate the come on, mom. We're gonna have to calculate the gradient because we have those two. The only thing we need for angle of inclination is the gradient, right? So change in y over change in x, that's gonna be -4 -2 over -1 -5, that is -6 over -6, that is 1, right? So here you're just gonna say tan -1 equals to your degree, which is what? We go there, 145, right? That was a bit easy. And then look at this line. This line, and the gradient is what? The gradient is 0 because you have y equals to 4. It's in that case. So in this case where you have y equals to 0, no, y equals to 4, it's, say you have your Cartesian plane, and your Cartesian plane, yeah, you have your Cartesian plane, and on your Cartesian plane you have y, which is equals to 4, y equals to 4. Remember here I said that since your y values are the same throughout, you're gonna have y 4 minus 4 over change in x, which is 0 over change in x, which is 0. Yeah, so we're not gonna, yeah, so the gradient here is 0. So you just say tan, let's see what we get. Bang. 0. Yeah. Yeah. And I mean, so the angle of inclination in this case is just gonna be, I believe the answer should be 180. I believe. Let me see. Tan 180. Yeah. Yeah, it's gonna be 180, right? Because yeah, just it's a straight line. Measure that angle 180 degrees. Yeah, so he saw the angle is 180 degrees. um Here you're gonna have to do some recalculation to find your gradient. And here you have what? You have this line. So here your angle of inclination, we can say it's gonna be 45 degrees. So is the angle from your x-axis to your, to your what, to your line or your point, to your line. So here it's just gonna be 45 degrees, I believe. um Wait. Oh shit, I'm still recording. I thought I paused this thing. Damn. Okay, so let me talk. I thought I paused this thing. So no, number E, remember for number E, when you have a vertical line in that case our vertical line is uh on the other side, on the negative x values. So there, remember with the vertical line you don't have a gradient, you don't have a gradient. So if your gradient is not a real number, it doesn't exist. It's not. If your gradient is not a real number, then you know you we can just yeah just say no angle of inclination. Yeah, unfortunately this is something I kind of should have checked, but I didn't check it. But yeah, from just the simple knowledge that we have that there is no gradient here, we can just say that there will not be any angle of inclination. I don't know. Yeah. And then for D, I'm just gonna rearrange it for you, ne? For D you have x, 3y plus half, right? So you, okay, I yeah, okay, let me just solve it. You're gonna have, this is x minus half, uh and then we divide, no, this is 2. Then we divide everything by 3, 1 over 3, right? So this 3 cancels. Then you have y equals to what? On the other side you have 1 over 3 x minus 1 over 6. You don't care about this thing, you don't care about this last part. Your focus is here on your gradient, ne? You take that, you're gonna have your tan minus 1 over 3. Then you get your angle of inclination, right? Shift tan 1 over 3, and yeah, then you have like 18.4. Yeah, 18.4. So I mean that's what's up. That's what's up. Yeah, bros. Yeah, man. This is it. This is it, I believe. So yeah, it seemed like in this video I was rushing a lot, because even like solving this problem, it was a bit messy. Like, just look at this, man. This is so much messy. I don't know, it looks like I was rushing somewhere. Maybe it's because of that call I got. But yeah, good luck guys, all the best. See you in the next section.